Okay, so this is for number 7 on my exam. And so I'm gonna talk about, I didn't put any formula down, so that's mainly why I was wrong, and I accidentally chose the wrong answer. I put the wrong one down. So I'm gonna start off with what I have, which would be t is equal to 4. No, t is equal to 0. And v naught is equal to -3 meters. This 0 seconds. And then t1 is equal to 4 seconds. And v1 is equal to 0 meters. So, as shown in the graph, it's going to be -3 is going to be right here. And the line's going to start from here and go up to about about to +4. Let's just call it right there, 4. And that's going to be 3, 2, 1, 1, 2. So anyways, so as this part right here is going up to 0, it's going to be it's decreasing, so it's slowing down as it's in a negative area. But once it hits 0 and goes past 0, it's going to be increasing in speed. So what time is, so what I had wrong was, as t is going to be equal to 4 seconds, and at the same time time is going to be greater than 0, which means that it's going to decrease, then increase. You can see right there. So the answer is going to be answer D instead of E, which is what I put. And that's basically what the graph is showing. Okay, so this is for question A on the exam. And what I did wrong here, as you can see, is I did not finish the equation, which would change this answer to a 0. So as you see, I'm going to correct that now, so it's going to be x of t, well, I guess I should show you what my t is equal to 30 seconds, and t is also equal to 40 seconds. So x of, oh gosh, can't see it. So x of t is going to be equal to 3.5 meters a second times t plus, or sorry, no, minus 5.00 meters a second squared times t squared, as you can probably see right there. So that's what I have known. So what I got was xt is equal to 3.5 meters. Yeah, you can see that, okay. A second times 0.30 seconds minus 5.00 meters a second squared times 0.30 seconds squared. As you can see there. And then which of course is equal to 0.6 meters. And then x, now for the 40, which is x t is equal to 3.5 meters a second times 0.40 seconds minus 5.00 meters a second squared times 0.40 meters, I said second squared, which is again also equal to 0.6. So with that, x of t is going to be equal to 0.6 minus 0.6. Just cancel those. That's canceled. So it's going to be like meters a second if I'm correct. This is all meters a second. Over 0.30 minus, no, minus 0.40, which is going to be equal to 0 meters a second, which will be my answer for 8 on the exam. Okay, so this is going to be for number 9 on the exam test. And so I used the wrong equations on the first two, but I got down here correct. Probably. Anyways, so I'm going to be working on A and B and C. So first one's A, which is going to be, well, I got that wrong because I divided 15 by 2, which is 7.5, which is not right. So what I'm supposed to do with this, it's going to be, so we need to find the time necessary for the car to reach the truck, which will be x is equal to x times t, x times t plus 1/2 times a times t squared, which is x is equal to, since we know our knowns and all that, which is the car, which is x, which is x, we'll just say x1, is going to be equal to 0 as it starts from rest, and then it accelerates at 2.00 meters a second squared. And then, so we'll know the truck, which is, I'll say x2, which is equal to 15 meters a second, which is its velocity. I can just say v. So that known, okay. So we're going to be, the equations, well, I'll have to rearrange it to find the time. So since x is going to be 0, which that's going to be x1, it's just going to be 1/2, 1 over 2 times 2.00 times t squared, because we don't know t yet, which is going to be x. So 1, that's going to be 1 times t squared, x is equal to t squared, okay? And so now that we know we have that correct, we're then going to go to the truck, because we need to add up both of them. So since we already know the velocity, which is, so we're just going to plug that in, which is t squared is equal to 15t, t squared minus 15t is equal to 0. And we're going to formulate it, which is going to be t times t minus 15 is equal to 0. With that in mind, now we know that t is going to be equal to 0 or 15, which is our seconds. So 15 is where the car passes our truck, or catches up to it. So then we find the distance, which is going to, so this is basically A. Then the distance of, we need to find the distance beyond the traffic light where the car passes the truck. And I sort of already had that down, but it was in the wrong place, which is basically just x is equal to v times t. So that's going to equal 15 meters a second times 15 seconds, which is just going to give us 225 meters, because the s's cancel out. Oh, we're just going to equal that right there. So now that we know the distance, we're going to have to figure out the speed of the car, which is c. And these are all subplotted like that, except for that one up there. It's gonna be like that. Anyways, so which is easy now that we know everything, which is which is equal to v I plus a times t. V is going to be equal to, as we said, or x. Either way, v is just easy to understand. 0 plus, that's going to be like v1, which is x1, as we showed up here. Plus 2 times 15, because now we know the time, which is v is equal to 30 meters a second squared. That is the speed at which the car is going to, when the car passes the truck, that's going to be the speed of it, because the truck is at a constant, it doesn't change at 15 meters a second. So that is how you're supposed to do it for a 9 on the exam test, which I did not do, but I did get that right, so I just didn't do it correctly. So just to get better showing of all I did. That's it. Okay, so this is going to be number 10 on my exam homework. So put that right there. So I need to write out my knowns, which is my VI, which is initial velocity, which is 0, because she accelerates at a constant rate of acceleration, I guess. And x is going to be equal to the distance, which is 60 meters. And okay, x is equal to VI. Oh, and my final velocity, which is VF, I always forget about that one, which is equal to 9.00 meters a second squared. Actually, you cannot see where I wrote that, so it's right there. So, with that, we're going to plug into our formula, which is VI plus 1/2 times A times T squared. So we're going to have to rewrite that because we need to find how long it took her to finish the race. So it's going to be x is equal to VI, no, just 1/2, because VI is, as shown, is 0. Actually, I could probably just keep that in this. So it's just going to be 0 plus 1/2 times. So we're going to since we're going to switch that with VF up here. So it's times 9 times T squared. So that's 60 is equal to 1/2 times 9 times T squared. Well, at this point, it's just T. So we've got a calculator here. It's going to be 0.5 times 9, 4.5. Now we're going to divide that by 60. 4.5 divided by 60 is equal to 13.33. So let me just switch this up. So it's T is going to be equal to 60 meters over 4.5 seconds, I guess. Meters a second, I guess. Which is then going to be equal to 13.33 seconds, because those cancel out. And that is our final answer for number 10. So you can see everything. That is what I have. That is how you do number 10, and that is what I did not do for the first time. Okay, so this is going to be the number 11 on my exam homework. And just write that here. So, this one, I'm pretty sure I just marked the wrong answers, because as shown on the graph, it wants to know what time intervals will the object be moving with non-zero constant acceleration. So with that in mind, non-constant acceleration, I would have to say, because it would probably be from 6.1 to 7.9 as it is decelerating, going down, which would make it possible as velocity changes, as the velocity x minus t slopes change, velocity changes, and acceleration also is non-zero. So, as it is, as I said before, decelerating, it is not really possible. It could be possible too, but right here at 4.1 to 5.9 seconds, as it is a constant velocity, there's no acceleration progress. So that would be probably 11. So, and while I'm here, I guess, so this is number 12 on my exam paper. And the question is objects that are dropped off a bridge at an interval of 1.0 seconds apart. During the time both objects continue to fall, their separation what? So it would be A, it increases, because as shown, so it's going to be unknowns, it's 1 second for the first between drops right here, and gravity, because we've got to take that, is equal to 9.8 meters a second squared, because at this point they're free falling. So we've got to write out the formula for the first one, which is x is equal to 102 times gt squared, which we can rewrite it to, it can be also written x is equal to g times t squared, which over 2, which is x is equal to 9.2, that's a 9, mine times, I guess, 1 squared over 2, which is going to be 4, wait, hold on, let me get my, it's going to be, wait, that's, why did I put 9.2, that's 9.8, my bad, 9.8 divided by 2 is equal to 4.5, 4.9, okay, and so that's for the first rock. Well, so, okay, my parents called me, so, for the second one, if they're 1 second apart, so that's the initial separation is 4.9 meters, meters a second, meters. So, for the second one, I'm just going to say, it's going to be the same formula. It's going to be x is equal to 9.8 times, but it's going to be 2 this time because you're giving it a second before they drop. I'm giving them a second. So that's going to equal, bring up my calculator, it's going to be 9.8 times 2, square root of 2 divided by 2. It's going to be 19.6 meters. That's shown here. It's 19.6 meters. And then now it's going to be, well, I don't need to show any answers for that because we're just going to know that now it increases as shown right there because it's going to continuously even if we add like 3 to that or whatever, because they're going to always be separate. Now it's going to be 3, that's going to be 4. It's going to always increase until they hit the ground. It's always going to be 1 second more before it hits the ground. So okay, so this is number 13 on my physics exam. I need to find the velocity at which the second rock was thrown. So I'm going to write that down our knowns, which is the initial velocity, which is 0 because the first rock was dropped. This is all for the first rock, the first portion, because we need to find the distance. So we got that. We got t1 is equal to 3 seconds. t2 is equal to 2.00 seconds, as shown right here. So, and so we're going to be using gravity for this form. So it's going to be x is equal to vi times t plus 1/2 times g times t squared. So x is going to be equal to, because that vi is 0, it's going to be 1/2 times g times t squared, which is x is equal to, I'll just write like that, 1 times 9.8, 9.8, and t2 squared is going to be 3 squared, which x is then going to equal, let's put this in the calculator, 0.5 times 9.8 times 2 squared is going to equal, I put it in wrong, 44.1. As shown here. Right, there it is. As shown there. So, with that as our known, it's going to be, I'm going to have to switch all this up because now we're going to have to turn it into meters a second. So, x is I'll just make it x because I don't really, it's not right, but it's going to be 44.1 minus 1/2 times 9.8 times 2.0 squared over 2, which that is going to equal, just put it into the calculator, minus 0.5 times 9.8 times 2 squared divided by, that didn't work. There we go. Okay, 44.1 minus 0.5 times 9.8 times 2 squared is equal to 24.5. 24.5 divided by 2 is equal to 12.25 meters a second. So that is our velocity at which the second rock was thrown to get to 2 seconds right here. So our final answer is 12.25. This is number 15 of my physics exam homework, and I need to find the components of vectors, which are, I'm assuming, a and b. So a is pretty simple, ax, which is pretty simple, as ax is equal to 0, a cosine 0 degrees because it's a on the x-axis, and ay is basically pretty simple because it's going to be well, you need to make it cosine, so it's going to be ay is equal to a sine of 90 degrees minus 90 degrees, which is equal to a cosine 90 degrees. So that's the A section. And I could really just figure out from there, but I have to finish. So, actually I can't, yeah I can, but I need to show B. No, can't see it. So, for BX, it's going to be, this one's going to be trickier because we got that 30-degree angle in there, which is right there. So, B of cosine is times 90 degrees plus 30 degrees, which is going to be equal to B cosine 120 degrees, which is equal to B cosine 180 degrees minus 60 degrees, which is negative B cosine 60 degrees. That's what that is. So that's for BX. And then for BY, it's going to be B is equal, or B sine times 90 degrees plus 30 degrees is going to be equal to B sine 30 degrees. So my answer, instead of having it as A, is actually going to be C, which is AX is equal to A cos 0 degrees, BX negative B cosine 60, AY A cosine 90 degrees, and B cosine 30 degrees. That is my final answer, and what I did wrong, I didn't actually put any formulas or do this correctly, I just circled the first one. That was what I did wrong.